This video is for question number 14 of the January 2017 Algebra 1 Common Core Regents, and I would say this is probably the most difficult on the question on the test, pardon me, thus far. They do certainly get harder as we go, but this one is actually a pretty difficult question to conceptualize. So here we have a computer application generates a sequence of musical notes using the function fn is 6 times 16 to the n, where n is the number of the note in the sequence and fn is the note frequency. Which function will generate the same note sequence as fn? What this really means, the same note sequence, is which of this function is equivalent to our function. So if worst comes to worst and you really can't solve this, you could certainly graph this in the calculator and find which one is exactly the same as 6 times 16 to the n. But that does actually become a little bit thorny because the numbers get very large and all the functions do kind of look the same. So we would strongly recommend back solving this question because any of these, they're all expressed somewhat differently. So we'll probably want to try to find an equation that will turn up the exact same function as this. So let's start with g to the n. Now you'll note that in our original function, the n is by itself in the exponent, whereas here we actually have some coefficients of n. So we have to remember one of our very important laws of exponents, and that's x to the a all raised to the b is x to the ab, meaning if I have 4 to the third and it's raised then to the n, that's equivalent to 4 to the 3n. We're going to be using this, but we're actually going to be going backwards in this case. So the first thing that I would do here is take a look at number 1, and what we have is 12 times 2 to the 4n, and I would go ahead and change that 2 to the 4n to 2 to the 4th to the n using this property. So we have a power raised to a power and a multiplication of those two powers. So that's what I'm doing here. Now 12 times 2 to the 4th is 16 to the n. This is really close, but you'll note that we have a 12 here and we have a 6 here. So certainly this is not the same value. So g of n is not our answer. Choice number 2, down here, we have 6 times 2 to the 4n. And you should kind of recognize that this portion of this is actually exactly the same as this one. So we could use the exact same process, and what we'll do is we'd raise 2 to the 4th to the n. Well, we already know 2 to the 4th is 16, so this is 16 to the n, and then times 6. So our h of n is exactly that from question number 2, answer choice number 2, and that exactly matches our original f of n. So the answer must be 2. The problem with choice 3 is that, again, we have the 12 on the outside, not 6, and the problem here is that 8 squared is 64. So it's not going to be 16. So the answer is choice 2, and the best way to do that is to back solve it. Now you could also solve this somewhat logically and say, okay, well 16 is either 4 squared or 2 to the 4th. So split this up and say, okay, if I do 4 squared, I'm going to get 6 times 4 to the 2n using our other property. Here, this time we're going front ways. That's none of the answer choices. So the other one would be, well, 16 is 2 to the 4th. Again, we can make this very easy to see here. 16 is 4 squared. There's our 4 squared, and we use the exponent law to achieve that. And here it's 2 to the 4th. And we're going to use our exponent law to achieve this. Well, guess what? This matches up perfectly with answer choice 2. So either way you do it, you'll end up with the same answer, choice 2.